In this area problem, the question is again asking us to find the area of the region bounded by the graphs, but this time we're not given the x intervals as clearly as we did in the prior problem. So let's take a look at what's happening here. We've got two functions, f of x equals 2 minus x squared, and g of x equals x. So generally, we should be able to sort of guess what this should look like. We know f of x equals 2 minus x squared is going to be a parabola that's facing down with a y-intercept of 2. So we could generally draw, this is a horrible looking graph, but we can generally draw something that looks like this for 2 minus x squared. We also know that g of x equals x is going to be something with a slope of 1 over 1, a 45-degree linear equation that's just going to go right through this graph. So something like that. It should go through the center of the origin, but you guys get the shape. So in looking at the shape, we automatically see that there's now a region bounded. So in this problem, we're looking for this region. And if we look a little closer, we can automatically identify which function is going to be the function with a higher y value the whole time. And what we need to find is our x1 and x2 values so we can set up our integral. So let's go about doing that. We've got f of x equals 2 minus x squared. So I already know that that is going to be the function with a higher y value just based off how the picture looks. Minus my x with respect to x integral, and it's going to be from x1 to x2. So we've got everything here ready to go to find the area, but we now need to get the intersection and find the values of x1 and x2. So to do that, you should be able to do that on your own. We would set this up to be equal. And after we do a little math, we end up with this. Negative x squared minus x plus 2. And if we solve that, we'll quickly find out that the x values are going to be negative 2 and 1. So that means my integral can be set up this way. And then I just proceed. So we've got 2 minus x squared minus x. So let's set that integral up as negative x squared minus x plus 2. From negative 2 to 1 dx, get our integral. So we're going to have negative 1/3 x cubed minus 1/2 x squared plus 2x evaluated from negative 2 to 1. We always start with the top sum. So we're going to start with 1, and we get negative 1/3 times 1 cubed minus 1/2 times 1 squared plus 2 times 1. We're not done. I'm going to use brackets to show that I finished half of this evaluation. Now I'm going to use negative 2. Follow the same setup. I've got my negative 1/3, negative 2 cubed minus 1/2 of negative 2 squared plus 2 times negative 2. All right, we are all set, and now you just need to check your work. So if you evaluate this correctly, you will end up with the value of 9/10.